Welcome to the world of Dart programming. This comprehensive video series is designed specifically for new programmers and developers who want to learn Dart from the ground up. Dart is a modern, object-oriented programming language developed by Google. It's designed to be platform independent, meaning you can use it to build applications that run on multiple platforms from a single codebase. Dart is most famous for its use in Flutter, Google's framework for building cross-platform applications. With Dart and Flutter, you can create mobile apps for both iOS and Android, web applications, and even desktop applications, all from a single code base. Dart is particularly beginner-friendly because its syntax is very similar to JavaScript, making it relatively easy to pick up for new programmers. It combines the flexibility of dynamic typing with the safety of static typing, and comes with excellent development tools. Throughout this comprehensive series, we'll cover everything you need to know to get started with Dart. We'll begin by setting up your development environment, then dive into Dart fundamentals, and finally build a complete command line application together. By the end of this series, you'll have a solid foundation in Dart programming and be ready to start building your own applications. So let's begin this exciting journey into the world of Dart programming. Dart programming language has experienced tremendous growth in recent years, and 2025 presents the perfect opportunity to add this powerful language to your skill set. Dart's popularity is surging primarily due to its role as the programming language behind Flutter, Google's revolutionary cross-platform development framework. This architecture diagram shows how Dart sits at the framework layer, providing the foundation for building beautiful native applications. One of Dart's most compelling advantages is its ability to enable true cross-platform development. With Dart and Flutter, you write your code once and deploy it to both iOS and Android platforms. This dramatically reduces development time, maintenance costs, and ensures consistent user experiences across devices. Major technology companies have recognized Dart's potential and adopted it for their critical applications. Google uses Dart for Google Ads and Google Pay. BMW has built their mobile applications using Flutter and Dart. Alibaba leverages Dart for their e-commerce platforms. These industry leaders chose Dart for its exceptional performance, developer productivity, and seamless cross-platform capabilities. The job market for Dart developers is experiencing remarkable growth. Statistics show that over 50% of developers are looking to adopt new technologies in their next projects, and Dart consistently ranks among the most sought-after skills. As more companies recognize the benefits of cross-platform development, demand for Dart expertise continues to surge, making it an excellent career investment for 2025. Learning Dart in 2025 positions you at the forefront of modern software development. With its growing ecosystem, industry adoption, and increasing job market demand, Dart offers developers the opportunity to build efficient, beautiful applications while advancing their careers in an exciting and rapidly evolving field. Setting up the Dart SDK is a straightforward process that involves four main steps. We'll download the SDK, extract it, configure our system path, and verify the installation works correctly. Step 1. Download the Dart SDK from the official Dart website. Navigate to dart.dev and look for the SDK download section. Choose the appropriate version for your operating system. Step 2. Extract the downloaded zip file to a location on your computer. Choose a directory that's easy to remember, such as c:\\Dart SDK on Windows or /usr/local/Dart SDK on Mac and Linux. Step 3. Add the SDK's bin directory to your system's path environment variable. This is crucial because it allows you to run Dart commands from anywhere in your terminal or command prompt. Step 4. Verify the installation by opening a command prompt or terminal and running dart-version. If everything is set up correctly, you should see the Dart version information displayed. Congratulations! You have successfully set up the Dart SDK on your system. You can now run Dart commands from any directory in your terminal. In the next section, we'll configure Visual Studio Code for optimal Dart development. Visual Studio Code, commonly known as VS Code, is one of the most popular and powerful code editors available today. It's free, lightweight, and packed with features that make coding more efficient and enjoyable. To get started with Dart development in VS Code, you'll first need to download and install VS Code from the official website. The installation process is straightforward and works on Windows, macOS, and Linux. Once VS Code is installed and running, you need to configure it for Dart development. The key is installing the Dart extension, which provides all the essential features for working with Dart code. To access the Extensions Marketplace, click on the Extensions icon in the left sidebar, or use the keyboard shortcut Ctrl-Shift-X on Windows and Linux, or Command-Shift-X on macOS. In the Extensions Marketplace, search for Dart in the search box. You'll find the official Dart extension published by Dart Code. Click the Install button to add it to your VS Code installation. The Dart extension transforms VS Code into a powerful Dart development environment. It provides syntax highlighting to make your code more readable, intelligent code completion to speed up development, and integrated debugging support to help you find and fix issues quickly. Additional features include error detection and linting to catch problems early, code formatting to keep your code clean and consistent, and Flutter support if you plan to build mobile applications. With the Dart extension installed, VS Code becomes your complete Dart development workspace. While manual SDK installation works well, package managers offer a more streamlined approach. They automatically handle dependencies, configuration, and updates, making the installation process much simpler across different operating systems. On Windows, Chocolatey is a popular package manager that makes software installation effortless. Simply run the choco install Dart SDK command, and Chocolatey will download, install, and configure the Dart SDK automatically. On macOS, Homebrew is the go-to package manager. The installation requires 2 steps. First, add the Dart language repository with brew tap dartlang/dart. Then install the SDK with brew install Dart. Homebrew handles all the configuration automatically. On Linux systems, the apt package manager provides a straightforward installation method. Start by updating your package lists with sudo apt-get update, then install the Dart SDK with sudo apt-get install Dart. This ensures you get the latest available version. Package managers offer significant advantages over manual installation. They automatically resolve dependencies, configure your system path, provide easy updates and version management, and ensure you're installing verified packages from trusted repositories. This makes them the preferred method for most developers. Now that we have Dart set up, it's time to write your very first Dart program. We'll create the traditional Hello World program that every programmer starts with. First, open Visual Studio Code and create a new file. Name it hello.dart. The .dart extension tells the system this is a Dart source code file. Now, let's write our first Dart program. Every Dart program starts with a main function. This is the entry point where your program begins execution. Type the following code exactly as shown. We start with void main, followed by opening and closing parentheses, then opening and closing curly braces. Let me explain each part of this code. The word void means this function doesn't return any value. Main is the name of the function. This is where Dart starts running your program. The print function displays text to the console. Notice the single quotes around Hello World. This creates a string. Every statement in Dart ends with a semicolon. Now save your file. You can use Ctrl-S on Windows or Command-S on Mac. Make sure the file is saved with the .dart extension. To run your program, open a terminal or command prompt. Navigate to the directory where you saved your hello.dart file. Type the command dart hello.dart and press enter. This tells Dart to compile and run your program. If everything is correct, you should see Hello World printed in the terminal. Congratulations! You've just written and executed your first Dart program. This simple program demonstrates the basic structure of every Dart application. The main function is your starting point, and print allows you to display output. You're now ready to explore more Dart features. Variables are the fundamental building blocks of any programming language. In Dart, variables are named storage locations that hold values in your program. In Dart, you can declare variables in 2 main ways. First, using the var keyword, which lets Dart automatically determine the type based on the value you assign. The second way is to explicitly specify the data type. This makes your code more readable and helps catch errors early during development. Both approaches are equivalent and produce the same result. Dart is statically typed, meaning each variable has a specific type. But type annotations are optional because Dart can infer types automatically. When you declare a variable, Dart allocates memory to store its value. Variables can be reassigned to point to different memory locations, as shown in this memory allocation diagram. Here's a practical example showing how variables work in a real Dart program. The variable myAge is declared, and its value is printed to the console. Understanding memory management is crucial. This diagram shows how variables in the stack point to actual values stored in the heap memory, demonstrating the relationship between variable names and their stored values. Key takeaways about Dart variables. They are named storage locations. You can use var for type inference or specify types explicitly, and Dart's static typing with optional annotations gives you both flexibility and safety in your code. Dart provides two main numeric data types for working with numbers: integers and floating point numbers. Understanding these fundamental data types is essential for any Dart programmer. Dart has two main numeric data types. The int type represents integer values or whole numbers, while the double type represents floating point numbers with decimal places. The int data type represents integer values. These are whole numbers without any decimal points. Examples include positive numbers like 1, 2, and 100, negative numbers like -5 and -17, and 0. The double data type represents floating point numbers, which are numbers that can have decimal places. Examples include 3.14 for pi, -2.5, and 19.99 for a price value. Here are practical examples of declaring numeric variables in Dart. We can declare an integer variable called age with the value 30 and a double variable called price with the value 19.99. Notice how we explicitly specify the data type before the variable name. Dart also supports type inference using the var keyword. When you use var, Dart automatically determines the data type based on the assigned value. For example, var quantity equals 10 is inferred as an int, while var temperature equals 98.6 is inferred as a double. This summary table demonstrates various numeric variables in Dart. We can see integer variables like number with value 1 and sum with value 500, as well as double variables like radius with value 5.5 and area with value 95.0334. Each variable has its appropriate data type clearly specified. Remember these key points about Dart's numeric data types. Int is used for whole numbers, double is used for decimal numbers, and you can either specify the type explicitly or use var to let Dart infer the appropriate type automatically. In Dart programming, two fundamental data types you'll work with frequently are strings and booleans. These data types form the building blocks for handling text and logical values in your applications. Let's start with the string data type. In Dart, a string represents text data, any sequence of characters like words, sentences, or even symbols. One of the great features of Dart strings is that you can use either single quotes or double quotes to define them. Both approaches are completely valid and equivalent. Here's an example using single quotes. We declare a string variable called message and assign it the text "Hello World" enclosed in single quotes. And here's the same concept using double quotes. We create a string variable called name with the value Dart programming enclosed in double quotes. Both methods work identically. Strings in Dart support various operations. For example, you can concatenate strings using the plus operator. Here we combine first name and last name with a space to create a full name string. Now let's move on to the Boolean data type, which is equally important for controlling program logic. The Boolean data type, represented by the keyword bool, is used to store logical values. A Boolean can only have one of two possible values, true or false. Think of Booleans as simple yes or no answers, on or off switches, or true or false statements. They're essential for making decisions in your programs. Here are examples of Boolean declarations. We can create a Boolean variable called isDartFun and set it to true, or create isComplete and set it to false. Notice that true and false are keywords in Dart. They don't need quotes. Booleans are often used in logical operations. Here we use the AND operator, double ampersand, to combine two Boolean values. The result can access will be false because both conditions must be true for AND to return true. To summarize, Strings handle text data and can use either single or double quotes, while Booleans represent logical true or false values. Both are essential data types you'll use constantly in Dart programming for building robust applications. Arithmetic operators are fundamental tools in Dart programming that allow us to perform mathematical calculations on numbers. These operators work with both integers and floating point numbers. Before we dive into arithmetic operators, let's understand what operators are. Operators are special symbols that tell the computer to perform specific operations on values or variables. Dart provides 5 main arithmetic operators for mathematical calculations. Let's explore each one with practical examples. The addition operator, represented by the plus sign, adds two numbers together. For example, 5 plus 3 equals 8. The subtraction operator uses the minus sign to subtract one number from another. 10 minus 4 gives us 6. The multiplication operator uses an asterisk to multiply numbers. 6 times 7 equals 42. The division operator uses a forward slash to divide numbers. 15 divided by 3 equals 5.0. Notice we use double for division results. The modulo operator uses the percent sign to find the remainder after division. 17 modulo 5 gives us 2, which is the remainder when 17 is divided by 5. Let's see these operators in action with a practical calculator example that demonstrates all 5 arithmetic operations. Here's a complete Dart program that demonstrates all arithmetic operators. We declare two variables, a equals 20 and b equals 6, then perform all 5 operations and print the results. When we run this program, we get the following output. Addition gives us 26, subtraction gives 14, multiplication results in 120, division produces approximately 3.33, and modulo returns 2. These arithmetic operators form the foundation of mathematical calculations in Dart. You'll use them frequently when building applications that need to process numbers, perform calculations, or manipulate data. Dart provides two important categories of operators for making comparisons and combining conditions: relational operators and logical operators. Relational operators compare two values and return a Boolean result, either true or false. Let's examine each relational operator. Here are all 6 relational operators. The double equals checks if two values are equal. Not equals checks if values are different. Greater than and less than compare numerical values. Greater than or equal and less than or equal include equality in the comparison. Now let's explore logical operators, which combine Boolean expressions to create more complex conditions. The AND operator requires both conditions to be true. The OR operator needs at least one condition to be true. The NOT operator flips the Boolean value from true to false or false to true. Let's see how we can combine relational and logical operators in a practical example. Here's a practical example combining both operator types. We check if someone is valid based on age and score. Let's evaluate this step by step with sample values. The expression evaluates each condition separately, then combines them with the AND operator. Since both conditions are true, the final result is true. Understanding relational and logical operators is essential for creating conditions in your Dart programs. They form the foundation for decision-making in your code. Control flow statements are fundamental programming constructs that allow your program to make decisions and execute different blocks of code based on specific conditions. The most basic control flow statement is the if statement. It evaluates a condition, and if that condition is true, it executes the code block inside the curly braces. Often, you want to execute different code when a condition is false. This is where the else statement comes in. It provides an alternative path of execution. Let's visualize how if-else statements work using a flowchart. This diagram shows the decision-making process that occurs when your program encounters conditional statements. When you have multiple conditions to check, you can chain them together using else-if statements. This creates what's called an if-else ladder, allowing you to test multiple conditions in sequence. Here's another flowchart that specifically shows how if-else-if chains work. Notice how each condition is tested sequentially and only one path is executed. Let's look at some practical examples. Here we have a number checker that determines if a number is positive, negative, or 0, using if-else statements. Here's another example that checks if someone can vote based on their age and citizenship status. This shows how you can combine multiple conditions using logical operators. Remember these key points about if-else statements. Conditions are evaluated as true or false. Only one code block executes in an if-else chain, and you can combine multiple conditions using logical operators. These statements form the foundation of decision-making in your Dart programs. The switch statement is a powerful control flow structure that allows you to execute different blocks of code based on the value of a single expression. It's particularly useful when you need to compare one variable against multiple possible values. The switch statement starts with the keyword switch, followed by an expression in parentheses. Inside curly braces, we define multiple case labels, each followed by a colon and the code to execute. Each case typically ends with a break statement, and we can include a default case for unmatched values. To better understand how a switch statement works, let's look at its execution flow using a flowchart diagram. The flowchart shows how a switch statement evaluates the expression once, then compares it against each case value. When a match is found, the corresponding code block executes. The break statement prevents execution from continuing to the next case, directing the flow to the end of the switch block. Now, let's see a practical example using a grade evaluation system. This will demonstrate how switch statements work with real code. In this example, we have a grade variable set to B. The switch statement compares this value against each case. Since the grade is B, it matches the second case, prints "good job, well done," and then breaks out of the switch block. Notice how the execution flows directly to the matching case B, executes the print statement, and then the break statement prevents it from falling through to the next cases. The break statement is crucial in switch statements. Let's understand why it's so important. Without break statements, the code will fall through to the next case. If grade is A, it will print "excellent," and then continue to execute the B case as well, printing "good job." This is usually not the desired behavior. Finally, let's discuss the default case, which handles any values that don't match the specified cases. The default case is optional, but highly recommended. It acts as a catch-all for any values that don't match the specified cases. This is particularly useful for handling invalid input or unexpected values, making your code more robust and user-friendly. Switch statements provide a clean and efficient way to handle multiple conditional branches based on a single expression. They're particularly useful when you have many possible values to check, offering better readability than long chains of if-else statements. Loops are fundamental programming constructs that allow us to repeat blocks of code multiple times. Instead of writing the same code over and over, we can use loops to make our programs more efficient and concise. The for loop is used when you know exactly how many times you want to repeat a block of code. It has a specific structure with three main components: initialization, condition, and increment. Let's break down each component of the for loop. The initialization sets up a counter variable, the condition checks if we should continue looping, and the increment updates the counter after each iteration. Here's a practical example. This for loop will print numbers from 0 to 4. Let's trace through its execution step by step to understand how it works. For loops are incredibly versatile. You can use them to iterate through ranges, process arrays, perform calculations, and much more. The key is understanding that they execute a fixed number of times based on your condition. Understanding for loops is essential for efficient programming in Dart. They help you avoid repetitive code and make your programs more maintainable. Practice with different starting values, conditions, and increment patterns to master this fundamental concept. In Dart programming, while and do-while loops provide powerful ways to repeat code blocks based on conditions. These loops are essential for creating dynamic programs that can handle repetitive tasks efficiently. The while loop is a fundamental control structure that repeats a block of code as long as a specified condition remains true. The condition is checked before each iteration, which means the loop may not execute at all if the condition is initially false. The syntax of a while loop is straightforward. We start with the while keyword, followed by a condition in parentheses, and then the code block in curly braces. It's crucial to update the condition variable inside the loop to avoid infinite loops. Here's a practical example of a while loop. We initialize a counter variable I to 0, then use a while loop to print numbers from 0 to 4. The condition I less than 5 is checked before each iteration, and we increment I inside the loop. Let's trace through this loop execution step by step. The loop will run 5 times, printing the current value of I each time, then incrementing I by 1. Iteration 1, I equals 0, condition is true, print count 0. Iteration 2, I equals 1, condition is true, print count 1. Iteration 3, I equals 2, condition is true, print count 2. Iteration 4, I equals 3, condition is true, print count 3. Iteration 5, I equals 4, condition is true, print count 4. The do-while loop is similar to the while loop, but with one key difference. It executes the code block at least once before checking the condition. This guarantees that the loop body runs at minimum one time. The do-while syntax starts with the do keyword, followed by the code block in curly braces, then the while keyword with the condition. Notice the semicolon after the closing parentheses. This is required for do-while loops. Here's the same counting example using a do-while loop. Even though the logic is identical, the structure ensures that the print statement and increment happen before the condition is checked. This flowchart clearly illustrates the key difference between while and do-while loops. The while loop checks the condition first, potentially skipping the loop entirely. The do-while loop executes the statements first, then checks the condition. This flowchart shows the do-while loop structure in detail. Notice how the code execution happens first, followed by the condition check. If the condition is true, the flow returns to execute the code again. If false, the loop terminates. To summarize the key differences, while loops check the condition before executing, which means they might not run at all, do-while loops execute the code first, guaranteeing at least one execution. Do-while loops are particularly useful for scenarios like input validation, where you need to prompt the user at least once. Both while and do-while loops are essential tools in Dart programming. Choose while loops when you need to check a condition before executing, and do-while loops when you need to guarantee at least one execution of your code block. Functions are one of the most important concepts in programming. They are reusable blocks of code that perform specific tasks, making your programs more organized and efficient. Every function in Dart has a specific structure. It consists of a return type, a function name, and parameters enclosed in parentheses. Let's examine each component. The return type specifies what kind of data the function will give back. The function name is how you identify and call the function. Parameters are the inputs the function needs to do its work. Let's look at a simple example. Here we have a function called add that takes two integer parameters and returns their sum. In this example, int is the return type, add is the function name, and a and b are the parameters. The function body contains the logic that adds the two numbers and returns the result. To use a function, you call it by writing its name, followed by parentheses containing the arguments. Here's how you would call our add function and store the result. When this code runs, the add function receives the values 5 and 3 as arguments, adds them together, and returns 8. This result is then stored in the variable called sum. Functions make your code more organized and reusable. Instead of writing the same code multiple times, you can create a function once and call it whenever you need that functionality. This example shows a more complex function that takes multiple parameters, including optional ones. Functions can be as simple or as complex as needed for your specific task. Understanding function structure is fundamental to writing clean, efficient Dart code. In the next section, we'll explore parameters and return types in more detail. Understanding function parameters and return types is crucial for writing effective Dart code. Parameters define what data a function needs, while return types specify what data it gives back. Let's examine the general structure of a function. Every function has a return type, a name, parameters in parentheses, and a body enclosed in curly braces. Parameters are the variables defined in the function signature that specify what inputs the function expects. Arguments are the actual values you pass to the function when calling it. Return types specify what kind of data a function will give back. Common return types include string, int, double, bool, and void. The void type means the function doesn't return any value. Let's see a complete example. This greet function takes a string parameter called name and returns a string. The function uses string interpolation to create a personalized greeting message. Functions can have multiple parameters of different types. Each parameter must specify its type, and when calling the function, you must provide arguments in the correct order and of the correct types. Understanding parameters and return types is essential for creating reusable type-safe functions in Dart. Always specify the correct types for your parameters and return values to catch errors early and make your code more maintainable. Lists are one of the most fundamental data structures in Dart programming. They provide a way to store multiple items in a single, ordered collection. A list is an ordered collection of items where each element has a specific position, called an index. Unlike some other data structures, lists allow duplicate elements. Here's a visual representation of a list containing 5 numbers. Each element has a specific position, starting from index 0. To create a list in Dart, you use square brackets and specify the type. Here we create a list of integers using the list angle bracket int syntax. You can access individual elements using their index position in square brackets. Remember, indexing starts at 0, so the first element is at index 0. This diagram illustrates how indexing works in data structures. Each element has a specific position that allows for quick access. One important characteristic of lists is that they allow duplicate elements. You can have the same value appear multiple times in different positions. This concept of duplicate elements in lists is fundamental to many programming tasks, such as counting occurrences or finding patterns in data. To summarize, lists in Dart are ordered collections with zero-based indexing that allow duplicate elements and provide direct access to elements by their position. Understanding lists is essential for Dart programming, as they form the foundation for working with collections of data in your applications. Sets are a fundamental collection type in Dart that store unique elements in an unordered fashion. Unlike lists, sets automatically prevent duplicate values, making them perfect for storing collections where uniqueness matters. A set is defined as an unordered collection of unique elements. This means that no matter how many times you try to add the same value, it will only appear once in the set. There are 2 main ways to create sets in Dart. The first method uses curly braces with initial values, while the second uses the set constructor. The first method uses curly braces to create a set with initial values. Here we create a set of strings containing 3 names. The second method uses the set constructor to create an empty set that you can populate later. This is useful when you don't know the initial values. The most important property of sets is that they automatically handle uniqueness. Let's see what happens when we try to add duplicate values to a set. In this example, we create a set with apple appearing twice. Notice that the duplicate is automatically removed. When we try to add apple again using the add method, it's ignored because it already exists. Sets are fundamental in mathematics and computer science. This diagram shows various set operations like union, intersection, and complement that you can perform with sets. Dart sets provide several useful methods for manipulating and querying the collection. Let's explore the most commonly used operations. Here are the essential set operations: add to insert new elements, remove to delete elements, contains to check if an element exists, length to get the size, and clear to empty the entire set. Internally, sets are often implemented using efficient data structures like binary search trees or hash tables. This diagram shows how a set might be organized internally using a self-balancing tree structure. Let's look at a practical example where sets are particularly useful, removing duplicates from a list of user IDs. This example shows how to remove duplicates from a list by converting it to a set using the toSet method. You can then convert it back to a list using toList if needed. This is a common pattern for data cleaning. To summarize, sets are collections that store unique elements only, can be created using curly braces or the set constructor, automatically ignore duplicates, and are perfect for scenarios where you need to ensure uniqueness in your data. Maps are one of the most useful collection types in Dart. They store data as key value pairs, where each key is associated with a specific value. Think of a map like a dictionary where each word has a definition. In programming, each key points to its corresponding value, creating a one-to-one relationship. Now let's see how to create maps in Dart. The basic syntax uses curly braces with colons to separate keys from values. Here we create a map called ages that stores names as keys and ages as values. The type annotation map string int tells Dart that keys are strings and values are integers. This diagram shows how elements are inserted into a map. Each key from 1 to 5 is paired with its corresponding value, creating the key value structure. Once you have a map, you can access values using their keys with square bracket notation. To get John's age from our map, we use square brackets with the key John. This returns the value 30 that's associated with that key. Maps are excellent for counting how often items appear. This example shows counting number frequencies in an array, where each number becomes a key and its count becomes the value. Let's see more ways to work with maps, including adding new entries and checking if keys exist. You can add new entries by assigning a value to a new key. Use contains key to check if a key exists, and remove to delete entries from the map. Maps are essential for organizing data where you need to quickly find values based on unique keys. They're perfect for lookups, counting, and creating associations between different pieces of data. Now we're going to build a practical project that brings together everything we've learned about Dart. We'll create a command line interface calculator that can perform basic arithmetic operations. Our calculator will be a command line application that prompts users for numbers and operations, then displays the results. This project will demonstrate how Dart can interact with the console and handle user input. First, we need to create a new Dart file. Name it calculator.dart. This file will contain all the code for our calculator application. To build our calculator, we need to use Dart's input-output library, known as Dart.io. This library provides essential functions for reading user input from the console and displaying output back to the user. The Dart.io library offers several key features, including reading input from the console, writing output, handling user interaction, and performing file operations. For our calculator, we'll primarily use the console input and output functions. Now we need to import the Dart.io library into our calculator file. At the very top of your calculator.dart file, add the import statement. The import statement, import Dart.io semicolon, tells Dart to include the input-output library in our program. This gives us access to functions like stin.readLineSync for reading user input and print for displaying output. Excellent. We've laid the foundation for our calculator project. We created the calculator.dart file, learned about the Dart.io library, and added the necessary import statement. In the next part, we'll create the main function and start building the actual calculator logic to handle user input and perform calculations. Now we'll implement the core input logic for our calculator. This involves prompting the user for input and converting their responses into the data types our program can work with. We start with our main function. This is where all our user interaction logic will be implemented. The main function serves as the entry point for our calculator program. First, we prompt the user to enter the first number. We use print to display the message, then stin.readLineSync to read their input. The exclamation mark handles null safety, and double.parse converts the string input to a double number. The stdin.readLineSync function is crucial for console input. It reads a complete line of text from the user and returns it as a string. Since we need numbers for calculations, we must convert this string using double.parse. Here's what the input reading code looks like in a real development environment. Notice how the IDE provides syntax highlighting and shows the program output in the debug console. Next, we ask the user to choose an operation. Since the operator is a symbol, we keep it as a string type. We don't need to parse it into a number. We'll use it directly in our logic. The user can choose from 4 basic arithmetic operations: addition, subtraction, multiplication, and division. Each operator will trigger different calculation logic later in our program. Finally, we prompt for the second number. This follows the same pattern as the first number. We read the input as a string and convert it to a double for mathematical operations. This example shows how string parsing works in practice. The program converts string inputs to double numbers and performs calculations. Notice how the IDE displays the successful conversion and calculation result. Here's our complete input logic. We systematically collect three pieces of information: the first number, the operator, and the second number. Each input is properly converted to the appropriate data type for our calculations. This is what our calculator looks like when running. The program prompts the user step by step, reads their input, and prepares the data for calculation. In the next part, we'll implement the actual calculation logic using this collected input. We've successfully implemented the user input portion of our calculator. Our program can now collect and properly format all the data needed for mathematical operations. In this final part of our CLI calculator project, we'll implement the switch statement to perform calculations based on the operator entered by the user and handle invalid input gracefully. The switch statement provides a clean way to handle multiple conditions. It evaluates an expression and executes different code blocks based on matching cases. The switch statement evaluates the operator variable and matches it against different cases. Each case handles a specific operator, and the default case handles invalid input. Here's our complete switch statement implementation. We declare a result variable, then use switch to check the operator. Each case performs the appropriate calculation and stores it in result. Notice the break statements after each case. These prevent the code from falling through to the next case. The default case handles invalid operators by printing an error and returning early. Here's our calculator running in the command prompt. The user selects addition, enters 10 and 10, and gets the correct result of 20. The switch statement successfully handled the plus operator case. If a user enters an invalid operator like %, our default case catches it and displays an error message, preventing the program from crashing. Our CLI calculator project demonstrates four fundamental Dart concepts: input and output handling with stdin and print, data type conversion from strings to numbers, control flow using switch statements, and proper error handling for invalid input. This completes our basic CLI calculator project. You've now built a functional program that demonstrates essential Dart programming fundamentals in a practical, real-world application.